Here I will show you implementing a binary to decimal decoder on a xilinx Spartan 3 FPGA board. First we will go to ISC project navigator, xilinx ISC project navigator. I choose 64-bit. Depending on your operating system you should choose your version. Then we will click file, new project, then I will type the project name. I have written decoder and then next, and here you will see I have already selected my board, Spartan 3E, and everything device is X3500E and everything. Here I will show you both VHDL and Verilog. So right now I choose VHDL. Later I will show you Verilog. It's a simple program. uh, First I will click that device that I selected, right click, then new, then here I will new source, then here I will select VHDL module and I type the file name. I can specify the UCF file later, so I select OK. Then here is my program body. Here you can see VHDL code has mainly two part. One is entity and another is architecture. So I include it is automatically included already by default. IEEE standard logic library. In the entity I will define the port, and I will define the port. Here I declare variable switch. This is a input port, so I typed in, and this is standard logic vector. As it is a 3 to 8 bit decoder, so I typed here 2 down to 0. That means 0 1 2. It's 3 bit here. And then I declare a variable light. It's a output variable and it's also a standard logic vector. And here I type 7 down to 0 because here it's 8 bit, 0 to 7. Then in the architecture body, after begin, I type process, and then I take switch as my parameter because the process run when the switch is pressed, any switch is pressed. So that's why here I type the case select function. So when switch is 000, that means binary 0, the light should be on, the first light should be on, because this is our binary first bit or first number, binary first binary number. So I put here it's a 8 bit. So I just copy paste, and then I change the binary increment in the switch variable. Here I will show that I'm making the lights on according to the decimal value switch. I am making the lights on, that means the LEDs on according to the decimal point. So I think also, sorry, I think yeah, here it should be. Oh, I missed a 0 because it's a 8-bit, so I included another 0, and here I put it 1. So from up to down is 0 to 7. So if I press 000, the first light should be on because it's the first uh, first number, that means 0. And then when I press 001, that means binary 1, the second light should be on. Then I put then I press and then I press again, right click to my device, that and click new source, then click constant file and file name decoder. You can write any name. Then I map my switch variable to my hardware switch, that means my switch in the FPGA board. So here you can see is a conventional way to do is net switch name, then the vector, the first member of the vector, or you can say member of the array. I put the location L13. How I find it? I found it from the datasheet of the xilinx FPGA 3 board. Here you can see the datasheet of the light, and here you can see in the datasheet here you can see the location of the switch and location of the switch. So I just copy paste. You can copy paste, or I can just see the location and I map my member of my vector to that location. Here is my light. In the same way, I map my map my light vector to the appropriate location. Here sorry if I forgot one thing. When I should include here others, that means if any case other than this case is pressed on the switch, so I should select here. In fact, when any press is no switch is pressed, no LED should be on. So then I run my program. It's synthesizing. It takes some time. After completing implement design, I click manage configuration project. You can click step by step, but I just click manage configuration project. Intermediate process will be done automatically, and impact will be open. That means the software that we use to program our xilinx FPGA, that program, that impact, that software is now open. So here I select file initial chain, then here I can just press OK, because I will select manually the file. I double click my device and I then select my bit file. I select no. Here I program, and you see the program is succeed. If you go to your xilinx FPGA board and press your switch you can see the result. I will show you the same program with Verilog. So I will close it. I will go to the new project. I will click the new project. Now I will write it at decoder 2. Here I should select Verilog. Then finish. Then same way we click our device. In fact, this is our FPGA. This device is our FPGA module. So here I select Verilog module and decoder 2 and finish. In the same way here we should write the Verilog. We should define two variable as argument of our module function. So here is input. Input is 2 to 0. It's like same as it is in the VHDL is 2 down to 0. Here it's 2 colon 0, 2 to 0. So it's input. Switch variable is our input, and light as it is 8-bit. So this is our light variable 7 to 0. Now here we are defining the switch as a signal. Is kind of signal, so I write it as where. Sorry for that, it's a mistake. And our light is register, so the variable is register type. Now here it's like the behavior part of VHDL, but here I'm writing Verilog. It's like always this will work always when the switch is pressed. So here I begin our program. Then I write a case select function. The case select function parameter is our switch variable. So if our switch is 3-bit variable, so when the switch is 3-bit 000, then our light register variable is 000, and the 8-bit is 1. I will write it. I will copy paste first, then I will write the exact switch position light position, which light should be on for our 3 to 8-bit decoder. Then here I just count down to binary value, just like 001. I hope you all know these things. So I end my case select. We should put semicolon here. So here I end my case, and then I close my begin command, and then end module. Here, so I add source. I right click my device and add source, and as I did not change the variable for the VHDL and Verilog, so the user constraints is the same file. So I just select my previous constraints file. Here is a mistake. It should be end case. End case should be, there is no gap between that. Then I click run, and it's synthesizing. It will take some time, as it always take. Then I click the configure target device. Then I directly click my impact, manage configuration project, because to go to the manage configuration project or the impact, the intermediate process will be done automatically. So I just double click impact, I mean manage configuration project, and it will open the impact and it will automatically generate the intermediate files. So now here is the same process as I have shown for VHDL. I will double click boundary scan, then I right click boundary scan, or from file initial as chain, and before that I should connect my device to my computer through USB. So it will find my device. The first one is my FPGA chip. So I double click it and show my bit file that has been generated by generating programming file. So I just showed it. I do not need the PROM, so I just click no. Then I click my device and then program. I click OK, and that's it. My program succeed. Now you should see to 3 to 8 bit decoder by controlling switch in your FPGA.